All right, welcome everyone to this week's SQL training for the 70-461 certification. Today we're going to cover T-SQL join types. I look at this as kind of a, retro or stepping back to something we should have covered in the very beginning, but we kind of overlooked. So today we're going to be going through join types. One of the things that's important if you're following along online, you can download this poster from my website at stevestedman.com. And that will help you. Everyone in the room's already got one, but before we get started, what I'm going to do is go back to the poster on the wall over here and have some destructive fun. This is what we've been using for the last 3 or 4 years as an example. It's much smaller and much more limited than what we just got now. So there's nothing like destroying a big poster in front of everyone on video. So moving on. Let me share my screen here and we will get started. So on to join types. Wow, this is a big agenda we've got today, but it's not, I think time-wise, we're probably going to get through it in about an hour, I'm hoping, but we'll see where we go with it. There'll be plenty of time for questions. So if anybody has any questions along the way or there's something you just don't feel comfortable with, please ask it and we'll hit it as we go. So we're going to go through pretty much everything you ever wanted to know about joins and probably some more beyond that too. We're going to be using Venn diagrams to represent this. And the first example we're going to look at here is just simply selecting from 2 tables. And I think everyone here, well, everyone watching probably gets select star from a table, just gives you all the rows back from it. But if we do 2 select statements like is shown here, what we're doing is getting 2 completely distinct sets of data. And I've drawn that with the Venn diagram here as table 1 and table 2 that are represented as 2 distinct sets with no crossover between either of those sets. There may be actual rows in those that would make sense to join or crossover, but they're simply just two tables returning 2 result sets. Now keep in mind as we go through this, everywhere that I'm referring to a table, table 1 or table 2, think of it as a set of data. That could be a subquery, it could be a derived table, it could be a common table expression, it could be whatever set of data that you're able to use in SQL Server. But for the simplicity and ease of the presentation, I'll be referring to those as tables as we go through here, go through the example. All right, let's take a look at our sample database. We're just going to create the database, and then I'm going to create 3 tables. I know it's horrible clean code to call them table 1 and table 2 and table 3, but for the purpose of syncing up with the poster in a very generic way, we're going to refer to them as table 1, table 2, and table 3. Table 1 has foreign keys. FK is one of them, and FK to table 3. So FK is just a foreign key to table 2, and FK to table 3 is a foreign key off to table 3. It's kind of a little bit sloppy here on the layout, trying to be more like real world where people maybe didn't put in a primary key correctly. But just to simplify it, we've got table 1 has names, and that will be some people. Table 2 has colors, and that will be people's favorite colors. And table 3 has just a field called data value. Who knows what we're going to put in that, but we'll take a look at that in a second. So we'll create these 3 tables that we're going to use for the example today. And then we'll put some stuff in it. We'll put in three foods into table 3, pizza, burger, and sushi, and that will represent your favorite food. Then we've got colors that we're putting in here into table 2 with IDs. And notice as we do this, one of the things that should jump out as that's weird is that red and indigo both have an ID of 1 in here. Now that could be a mistake in somebody's data, or it could be that for some reason those are both represented with an ID of 1. Also, as we look down below at the table 1, the thing you'll see is that as we insert a name, followed by the next value is the foreign key to table 2. So Steve with 1 tells me that my favorite color is red, but it's also indigo in this case based off of the data that's there. Aaron has a favorite color. Actually, I should have asked you, Aaron, what your favorite color was, but I just made this up with some sample data. Favorite color of 3, which says blue, and so on that way. And then the third column is foreign keyed off to table 3, and I've got a lot of nulls scattered about here. But if we look down at Beth down here, you can see her favorite color of 8 is yellow, and her favorite food is a 1, so it's pizza at that point. So we can see how some of these things are associated here. And it's specifically set up this way to help show what happens when we're trying to bring this data together. And you have some that are duplicates, you've got some that are nulls, you've got some that just aren't even used at all. And we'll go through that. And yep. Oh, question?
You need to show your screen.
Oh, I thought I did. Entire screen share. Whoops. All right. So sorry about that. I missed sharing the entire screen. It's coming through now for those in the broadcast. Thanks for whoever brought that up. So we'll fill those tables up with the data I've shown there. We've got 3 rows in the table 3, 9 rows in table 2, and 8 rows in table 1. Now, normally I don't go into this much detail, or we don't need to go into this much detail, but to understand how all the queries are working, it's really important to understand the data that we're looking at here. So to start with, select star from 2 tables. I'm just going to do the first example I showed on the slide. Select star from table 1 and select star from table 2. And actually what I'm going to do is open a new query window and save those 2 off in this other query window. Whoops. So that we can reference those quickly. So run those 2. I'm going to size this up here so we can see everything associated with it. And what we can see here in table 1 is all the people, and then the foreign keys off to the other tables. And most people don't have the favorite food based off of table 3, but the 3 at the end do. Most people have a favorite color except for the 2 at the end. And then here's the list of favorite colors. So we'll be referencing back to this output here quite a bit. So hopefully that's established the way the Venn diagrams work. We have 2 completely different sets at this point. All we've done is just select from those tables. Really basic, but that'll build our foundation to where we move into next. So next we'll take a look at the inner join. And a lot of people, when they first learn SQL, they just learn the word join. And technically you can just use join instead of inner join, and it's the same thing. However, it's a bit ambiguous. So the recommendation is always to use inner or specify the type of join you're doing, and that way it's clear that your intent was to use an inner join, not that you were thinking I'm doing an outer join or a left join in some way, and I accidentally forgot to put the keyword on there. So here, the way an inner join does with the Venn diagram is it takes everything from table 1 and matches it up with everything in table 2. Now, keep in mind, you may have additional where clauses here that filter it down to a smaller set of data, but with a simple set of data, it's taking everything from table 1 that's matched up with everything in table 2, and only where those 2 sets overlap, that's the result you're going to get back. And I think most people, I'm sure, are familiar with the inner join as we look at this, but we're building the foundation so we can move to the other one. So the way we do that is I'm going to do select star. I know normally select star is not good practice, but in the example here, I'm using it so you can see all of the columns that you get back, because depending on the join type or how we're doing things here, you may be getting different columns back based off of how that join is being done. So we're using the select star to be able to see all the columns that are being returned. And we're just saying select star from table 1, and I've aliased it as T1, inner join table 2, aliased as T2, and then I specify what it's joining on. Now, some people that when they first learn an inner join, they'll look at it and say, well, I've joined on these 2 columns, and then they find out, oh, those weren't really the right columns. They were joining on 2 integers or 2 IDs that look like they made sense, but when they joined, they realized, oh, it's not the right key relation or not the right foreign key relationship there. So you can't just pick anything out of the table. You have to be able to join on the right thing. So we'll take a look at the sample code here on that. So I'm going to turn on statistics.io as we go through this, and I'm actually going to turn on the execution plan so we can control M there so we can take a look at a few things. But here I'm just going to run the inner join that we just saw on the PowerPoint slide. And with the select star, let me zoom in on it here. The first 4 columns that we get back are all 4 of the columns from table 1. And then the next 2 columns we get back are all of the columns from table 2. And what we can see here, and I've got actually this tooltip popping up, but I can see that with Steve, that being me, favorite color being red. With Mary, favorite color is green. Aaron, favorite color is blue. But then because of the inner join down below, we see Steve also has the favorite color of indigo because of that data inconsistency that we had on two colors having the same ID. So it ends up showing that everyone who has red as their favorite color also has indigo as their favorite color at that point. And the way that the inner join works is that it brings together all the data from the tables, but you end up with duplicates. So with the inner join, you may end up with more rows coming back than you had in either table. And that's one of those things that comes up a lot of the times with the joins, is that you don't see real well in the Venn diagrams. Although it shows you the set of data that you're getting back, it doesn't show you necessarily how many rows you're going to get there. So with the inner join, it's bringing back everything that's matched up, and if there's duplicates, you get duplicate rows represented for both of those. The other thing, if we look at the messages here on the statistics IO, you can see that as we do the inner join, it's a very small table. So on table 1, it's doing a single scan with 2 logical reads. And on table 2, it's doing a single scan with 1 logical read. Okay, that's kind of what you'd expect, because it's just taking 2 very small sets and bringing them together. If we had, with some of the other join types we're going to look at, these numbers can change radically. So we'll see that as we go forward. Is there a question?
I was just curious, like, to solve that problem in this specific scenario, could you actually make the primary key on that table 1 include the ID and also the foreign key field so that it's kind of a composite?
Okay, so to solve the problem of reads, you mean, in table scans?
No, like more. You're basically saying there's bad data entry, right? Because there's a user ID with 2 different colors, and it's like.
Yeah. So the question was, could we solve that with a primary key with multiple columns in it? Well, technically, it's actually easier than that. If we had just gone, and I did this on purpose to sort of signify real-world data, but if I was building this table from scratch and I had this ID here, if I had simply made that an integer identity value and set that as the primary key like I did in table 1, and set the ID to be the same thing on table 2 and table 3, then that would have failed when I tried to insert 2 rows that were identical. Okay. But for the purpose of the demo and seeing what shows up, I did that on purpose.
Right. Yeah.
And real world, it happens that way a lot of the time, even though it's a bad practice. Okay, so inner join is taking everything, bringing it together, and just giving you those things that match up between the 2 tables. Next, on to the left outer join. Now, as far as syntax goes, sometimes people think, or do we have questions over here?
No.
Okay. Sometimes people refer to generally an inner join versus an outer join. And one of the great interview questions I like to ask to see if people know database joining is, can you describe the difference between an inner join and an outer join? And in that terminology, I just use the term outer join. Well, technically in SQL Server, there's no such thing as just an outer join. You either have a left outer join or a right outer join or a full outer join, but the word outer join itself doesn't describe what you're looking for. So the question, describe the difference between the two, is a little bit deceptive. You need to say, well, are we looking at an inner join versus a left outer join, or an inner join versus a right outer join, and go from there. Now, looking at the Venn diagram as we see it here, what we're doing with the left outer join is we're saying, give me everything out of table 1, but let's also join it up to table 2, and if there's a matched row in table 2, show me how that matches. But if the row doesn't match based off that on clause, then just fill in table 2 with nulls. Now, some people look at this, and actually from some stuff I put on Reddit, they look at this and say, well, can't I just say select star from table 1 and get the same thing? And that's where the Venn diagrams may be a little bit erroneous there, or not descriptive enough. If you said select star from table 1, you would get the same Venn diagram back, but you would not necessarily get the same number of rows. So for instance, if table 2 joined on a specific, based on the on clause here, had 2 rows that matched up like we were looking at with the favorite color, you would get more rows back based off of that. And because we're using select star here, that's going to say give us all of the rows from table 1 and table 2. So let's take a look at actually how that works here. So We're going to use the left outer join. All I did between the previous query where I used inner join and this query where I'm using left outer join was I replaced the word inner with left outer. Everything else is identical. So when we run this query, we see, and if let me zoom in on it here. If you look at the top set of data down to there, that's exactly the same as what you would have seen with the inner join, or what we did see with the inner join. 8 rows returned, and everything's matched up. You can see that my colors are red and indigo, Aaron's is blue, and so on down there, and that Fred also is red and indigo here, so that everything is matched up exactly as an inner join would work. But where you get the additional rows is on Johnny and Karen, who are here. They don't have a favorite color matched, foreign keyed into the table 2. So what they end up with is, here they are, but, oops, but where it's showing data from table 2 over here, it just fills it in with nulls. And that's where, if we just did a select star from table 1, the differences that we see is that we wouldn't get the duplicates like we do here on me and on Fred down here. And we wouldn't get these the other columns over here. However, the Venn diagram is very close to what it would look like if you just said select star from table 1. All right, now let's take a look at right outer join. So flip back and forth. All you can see at this point is that the Venn diagram is shifting from everything in table 1 instead to be saying, give me everything from table 2, but and match it up with everything in table 1. But if there's no match in table 1, then give me nulls instead. And that's where, if we look at the middle or the overlap section here, that's what would have been part of the inner join. And then everything else in table 2 is what's coming in as part of the left outer join. Now, the question came up as we were talking about this earlier, do you really need a right outer join? Couldn't we just switch the left and the order of the tables around? And if you have 2 tables you're joining like we're looking at here, absolutely. You could switch table 2 and table 1 in their order and achieve a right outer join by doing a left outer join with the tables reversed. But where it gets interesting and it doesn't work that easily is when you've got multiple joins going on. When you've got 3 or 4 or 5 of these, sometimes you need a right outer join from one table associated with a left outer join coming in from another table. And to switch them around isn't always feasible at that point. So that was a good question that came up earlier on that. So if we look here at the right outer join, all I've done is change the word left to right at this point. Run the query, zoom in on the results, and we have 3 that are showing nulls in the table 1 results. Those 3 that I've highlighted there are the results that we got because of the left outer join. Every other row besides those 3 rows would have come across in the inner join. What the left outer join did is it gave us everything on the right side over here. Mess up the zoom there. Everything on the right side. Sorry, I think I said that wrong a moment ago. What the right outer join did, because I think I referred to left outer join. What the right outer join did is it gave us everything from the right table, or the second table as it's being laid out here. And it matched it up where it could, like an inner join, to everything from the left table. And it filled in nulls on those things that weren't selected. So from this, we can look at it and determine that because pink, mauve, and orange are all nulls, that those are nobody's favorite color. Imagine that. Somebody's got to have, if we had enough people in our data set, somebody would probably have those as their favorites. All right, so next let's take a look at just the plain outer join here. We're going to say select star from table 1, outer join table 2. Incorrect syntax near the word join. The reason we get that is that there's no such thing as a plain outer join. It's ambiguous. SQL Server doesn't know what to do with it. It's missing one of the words, either left, outer, full, and we'll look at full outer join in a moment. But just plain outer join, if you get that error message, that's because you didn't include a left or a right on it.
Can you leave out outer and put in just left?
Let's take a look here. Can we leave out outer and just put in left? So that's what you're asking like that.
Yeah.
When we run that, absolutely you can.
Okay.
However, I don't recommend it,
Right.
because for people who aren't as experienced as you may be, or it's not clear as to what necessarily what you're asking for there, and it shows the intent that yes, I'm doing an outer join.
Right.
Technically, yes, it works, but I wouldn't recommend it. Okay, so then next, what about this one? Select star from table 1, joining table 2. What's that done for us? That's just an inner join. And technically, based on the SQL Server T-SQL syntax, that's totally fine. Based on the language, just say join. But in my opinion, it's ambiguous. And I like to always use an inner join there, just so that when somebody looks at it, that they're not as experienced or they're coming from a different database, that they know it is indeed an inner join. All right, on to semi-joins. And this is one of those that it's kind of a weird terminology. And this is one of those where we're going to see the difference with the select star a little bit here. So if you look at the Venn diagram on the semi-join, there's a typo that jumps out, obviously, at this point. The table 1 and table 1, it should be table 1 and table 2. My mistake on the typo there. But I don't want to imply that we're doing a self-join here by any means. But the semi-join is joining table 1 and table 2. It's probably that way on my slide as well. I'll have to go through and correct that. That'll be version 4 of the poster then. But table 1 and table 2 with the semi-join, and you might look at it and say, that looks just like an inner join. Is anybody feeling that way when they look at it? Okay, so the rows, the rows between the two sets that you get back will be the same rows. However, what comes out different with the semi-join versus the inner join is, in this case, you're only getting rows back, you're only getting columns back from table 1. You're not getting any of the columns back from table 2. And you're only getting those distinct rows back from table 1. So if a row from table 1 matches up with multiple from table 2, you're not getting multiple rows in that case. You're only getting single rows. And there's times where this is the best appropriate way to do things. There's times where the inner join is the best way to do things. It really depends on what you're trying to achieve. There are some performance implications or performance differences that you can get between the two of them, where because the select 1 from table here, where this and that, that comes across as a difference in performance, because all it has to do is determine, exist determines that at least one of these is there, rather than joining the entire table on all of the columns like we looked at earlier and doing a huge set between the two of them. So there are times where if the selecting the data in this, it's almost like a correlated subquery here. There are times that if it's selecting the data there, if it's inefficient or it's a huge set of data, sometimes it's better to do it this way versus using a straight inner join. And I say it depends, and that's where you really need to look at the query plan to determine the difference there based off the size.
Yeah, question on that one?
Yep.
That's the same as doing like where the F4 key is in and then just doing the select and returning the table 2's ID there.
No.
Wait,
Because
so
in that scenario, it would run that sub-select, which isn't filtered at all, every time, for every ID that it's looking at.
Okay.
Whereas the join, it narrows down the result set of that subquery.
however,
It
with
stops processing at the first instance because it doesn't exist.
yeah, the exists is a, like Aaron said, it stops. I mean, it gives you just enough to determine there's something there. It exists. That's it, and then it reports after that. So if we take a look at the semi-join and we run this, what we get back is all of those people who had a favorite color, because table 2 was the favorite colors table. So but we don't get duplicates on the favorite colors. And there's sometimes like you don't want that set of duplicates, and this is a much better way to do it. If we look at the messages here, there is a scan count of 1 on both tables. There's logical reads of 8 on table 2, so it's doing this quite a few times. It's running it 8 times, but it's doing it more efficiently with the exist than it would be with the in.
Okay.
But it does run it once for every one because it is like a correlated query there, subquery. And then the scan count on table 1, it's doing 2 logical reads as we go through that one. So difference in performance there based off the number of reads versus an inner join. And I mean, these numbers get hugely different when there's really big tables. So it really depends on what you're trying to do. Sometimes it's going to be faster to do it this way. Sometimes it's going to be faster to do it with a straight inner join and maybe do a distinct. But when you do something like that, it usually really slows things down. So quick show of hands in the room, semi-joins. How many people have heard that term or heard those before? All right, I'll be honest. Okay, well, it's one of those that Aaron's the only one, for those online, Aaron's the only one who raised a hand. I've used this many times, but until preparing for this presentation, I hadn't really thought of it as semi-join. And the way I found out about this was I put this out on Reddit and a bunch of people said, hey, what about semi-joins? So I figured, well, we better include that in here. And it was a great education because I threw out an example that didn't include it. So if anybody's looking at this and they've got feedback and they want to tell me, hey, what about this other one I missed? Great, send it to me and maybe I'll include it in the next training like this.
The places we are using in, should we be using that instead?
Depends.
It depends.
Yeah.
M is even different than
So-
joining and
So
existing.
so the question was, the places that we're using in, should we simply be replacing it with exists? And the answer is it depends. As it always is with those kind of questions. There are times where in is probably being used where it should be replaced with exist to do it this way, and it would be more efficient and it will give you what you need. There are other times where it's just not the right solution and it would probably give you the wrong results and bad performance. So yeah, blanket rules like that are never a good thing. Okay, now the anti-semi-join. Well, all we do in this one is we take the semi-join using the exists and we add the word not exists. So this is give me everything in table 1 that's not in, and I noticed I used the not in words there specifically, that's not in table 2. And you could achieve this in similar with a not in subquery, but it would be much more inefficient in that case. So we're saying give me table 1 that doesn't exist or that does not match up in any way with table 2 based off of the where clause that's specified in that inner query there.
Is that bottom line supposed to say average line, similar to average line?
You know, that was that was left over from the previous slide. Sorry about that. So the semi-join that we did is very similar to an inner join with less duplication. Good catch. That should not be on this slide at all. Thanks for catching that.
So the not exist though is potentially way worse in performance than exists because not has to go through them all.
Yes.
But if it does exist, it'll stop at that point and they'll return false. So it's faster than an outer join checking for nodes. Or not, I should say.
Right. So on this one here, if we're looking at this the select one from table 2, all it has to do is with the exists or not exists is go far enough to say, yes, there is one of them. And independent of whether it's exists or not exists, all it has to do is find the first one. And if there's none, yes, it has to scan the entire table or index or however it's getting it. But so they're fairly similar, I think, they're depending on the data that you're working with. So let's take a look at the anti-semi-join here. All I've put in is the not exist instead of the exists. And when we run this, you remember Johnny and Karen from the earlier example? Those are the people that don't have any favorite colors. So that's a way to get back all the people who are not part of that join. There's a few other ways to get that we'll take a look at here in a moment, but that gives you the people from table 1 who are not joined up with table 2 in any way. All right, so next let's take a look at the left outer join with exclusion. Now this is one of those that's really popular. And when you're trying to figure out who's in one table, what's in one table that's not matched up with another. However, we flip back here to anti-semi-join and left outer join with exclusion, our Venn diagrams are the same. However, when we look at the results, we'll see a slightly different set of data. Actually, in this one, no, let's take a look here. So left, that's not true. So in this one, if we look at left outer join, what we're saying is give me everything. Yes, we are going to get different set here. So everything from both tables, from table 1, left outer join table 2, on table 1 foreign key, so it's the same join we've been looking at all along, but throw out all of those where table 2's ID is null. Which I'm realizing left outer join with exclusion. So we run that, and at this point, no, I said that wrong. I said throw out all of those where it is null, but I stated that incorrectly. It's keep all of those where it is null. If we wanted to throw them out, we would have said is not null. So got that a little bit backwards there. But we're saying join them up with the left outer join like we did earlier, and keep all of them where the ID is null. The difference here is we get all of the columns back from both tables, even though they're both null. So if we compare the result set between the anti-semi-join and the right, went too far, the left outer join with exclusion, you can see we get the same people back. We get the same results out for the first 4 columns, but additionally on the second one, we get these other columns with a null. Now you could have got the same columns back by specifying something besides select star, but that's the reason I'm using select star in all the examples, is so you can see all of the data that's being returned or that could be returned at that point. When we look at the difference here on the performance, the logical reads on table 2 is the same between both of them. The logical reads on table 1 is the same between both of them. And the plans are slightly different, but 49% versus 51%, very close. Close enough that I wouldn't argue one way or the other with them. What we can see is we're doing a table scan on table 2 and a table scan on table 2 down below. The difference with the first one, the anti-semi-join, is that it's doing a top. Because all it needs is one result back before it can abort. So it uses the top to be able to say, give me just the top one out of there. If we look at the table scan here, we can see that it's being run with our actual number of executions. It's being run 8 times here. Oh, whoops. Oh, yeah. Actual number of rows is 6, and the estimated number of executions is 8. That's correct. So, but if we look down here at this one, the number of executions is 8. So the table scan is happening 8 times in each one, and that's why we get 8 pages being read. If it was a larger table, it would be 8 times the number of pages in that table to get your results back. However, this top is going to, in the anti-semi-join versus the left outer join, is going to stop the processing earlier and perhaps prevent reading some of those extra pages that are needed to be read at that point. I think the difference between the 49 and the 51% here would vary greatly if we had a much larger data set. So looking at the 2 of those, the anti-semi-join and the left outer join with exclusion give us the same result set back, slightly different columns, but the same rows, but they have different performance implications between the 2. And it might be in some cases that one works better than the other. Just gives you a different tool in your tool belt there to be able to work with. Now on to the right outer join with exclusion. Just like a right outer join, where we did before, but we're throwing out all of those that are matched up, and we're only keeping those where table 1 is null. So let's take a look at the right outer join with exclusion. Pink, mauve, and orange, which we determined earlier were the colors that nobody had as favorites. So it's a way to go through and find those things that aren't matched up there. You could do a similar thing with the anti-semi join if you simply switch table 1 and table 2 around in the query. You'd be able to get a similar result back there and give you another option versus the right outer join with exclusion. I think the right outer join with exclusion is much more common than the anti-semi join, just because I think people come across or figure it out a little bit quicker, but the anti-semi join or the semi join can give you some different performance implications there. Yeah, question?
You talked about the difference with that last example. You moved the where, the T1 foreign key is null, into the on.
Oh, that's a great
That
question. I'm really glad you asked that. So sorry, I'm getting too geeked out on the questions there. But the question is, if I take, and let me just jump back to the code and I'll show it. If I take the right outer join with exclusion, I copy this here, and the question was, if I take the where clause and put it into the on clause, that's what you're asking, right? So what we've got is a right outer join, and it's saying join it up where the foreign key matches the ID. So give me all of them where those two match, and give me all of them where the T1.foreign key is null. Now, as I phrase it that way, you might start seeing some of the issue with it. But the reason it's such a great question is I've seen this happen on many occasions. I've tried it myself and realized, oh, whoops, I shouldn't have done that. So when we run this, what do we get back? A very different result set. So what it's done in this case is it's taken everything from table 2 or the favorite color table, and it's matched it up with everything in table 1 where the foreign key is there correctly and where the ID is null, which says match it up with nothing, because there's no cases where they actually match and the ID is null. See the logic error there? And that's why I thought it was such a great question, because it seems simple the way it's asked, and the way you're typing it out is, why not put it in the on clause rather than in the where clause? So based off of the way SQL Server goes through the processing, if we go back to the first example here, what this does is it processes the part inside of the square there first. And it says, give me the right outer join, joining everything up. And then after it joins those together, it filters out all of them where it is null, rather than an invalid case that we have down below that says, give me where the foreign key equals the ID and the foreign key is null, which, as we've learned in previous trainings, there's never a case where null equals anything. Null has to be evaluated with is null or is not null. But we're saying, give me where null equals something, and no, give me where this ID is null and where this ID that happens to be null equals something, which never occurs. Does that clarify what you're looking for there?
No, I just wanted, yeah, you covered kind of the differences there, and that does clarify. But if there was actually a value, like again, T1 FK equals 1.
Yeah, I see where we're going. So let's take.
Pretty.
So if we just did a right outer join without the exclusion, let's just take a look at that example like we did earlier. If we run that, you can see that we've got all these people looking in here. And let's just say we want to look at only Fred. So right here, we could say where name equals Fred. I guess I should probably use quotes there, single quote. And that filters our results down to just Fred. Okay, but what if we moved it up here and said where those match and the name equals Fred? That's kind of what you had in mind, right?
Right.
So in that case, because it's an outer join, what we've got here is it's saying do this and do that, match it up like an inner join would. So we get this row of Fred and that row of Fred. But because it's a right outer join, give me everything else out of table 2 that doesn't happen to match table 1 based off of our on clause. This might be the results you're truly looking for based off of structuring it that way. However, if what we're really looking for is just just for Fred, and happen to display it if he doesn't have a color, like I think, let me look at the list here. If we look, oh here, no, I'm looking at the wrong one. But if we, so depending on what you're trying to do, one of those might be the right solution. A different one might be the right solution. But yes, they do perform differently. And generally though, if you're working with an inner join, that's one of those questions that comes up a lot of the time as well. If I move it from the where clause to the on clause, do I get different performance? Well, if you're working with an inner join and you're doing a similar thing, so let me just switch it here to inner join. Okay, it matches up, and we change the where clause to be an and in the on here. Yes, we get the same result. And sometimes people will ask me, especially when in the past working on reports and things, does it perform differently if I put that with an inner join, if I put that extra filter in the where clause versus in the on clause? And my observation in looking at that is it doesn't matter. And it doesn't matter because it appears no matter which way you do it, the SQL Server query parser figures out the right place to put it and will actually put it in the right place for you if it's an inner join. Now, that's been on SQL Server 2008 R2 and newer that I've observed that. I don't recall. I mean, it might have been on SQL Server 2005 or older. It may perform differently. But the difference between the inner join version of this with it putting in the and in a where clause like this, there is no, in my observation, there's been no performance difference between the two of those. In this case, we look at the scan and the logical reads, and again, it's a small data set, so it might not be truly indicative of what's going on, but they're identical. And the execution plan is identical, but what makes me think, and I've seen this with very large tables, that they've been identical, but the fact is, the table scans that are going on here are exactly the same, the clustered index scans are exactly the same, and they work out effectively to the exact same thing.
Which one do you think is cleaner?
Having them not in the joins. Having them all down below.
Yeah.
So the question was, which one is cleaner? Aaron answered, having them not in the joins, having it down in the where clause, and I would completely agree with that, because the on clause is where you're specifying how these two tables are going to hook together. The where clause is for filtering. Where you get into possibly some different confusion around it, or where that answer where I might not agree with that answer, would be when you've got many joins in a table or in a query. You might have 6 inner joins and 4 outer joins, and the where clause ends up being really huge and gets really hard to follow. It might make more sense to put those in on the on clause on a really, really big query. But on something small or simple, put it in the where clause, and it just makes a lot more sense.
And if the data you're looking for requires it to be in the join.
With outer joins, for
With the outer
instance,
joins,
yeah, you've
yeah.
got to, I mean, it performs different, of course, with outer joins,
Yeah.
like we saw a moment ago. But yeah, that was a great question. Okay, so now on to the full outer join. Select star from table 1, full outer join, table 2 on the ID. So this is going to say, give me everything from table 1, everything from table 2. If they happen to match up, show me where they match up. But if they don't match up, give me one table full of nulls or the other side of it full of nulls. It's kind of like if you did a left join and a right join and you union them together. Which, if you happen to be using MySQL, that's the way you have to do it, because full outer join is not supported this way in MySQL. but we're here to talk about SQL Server today. So we take a look at it. You can see, we'll zoom in on it and take a look at the results on the full outer join. The first set we can look at here, that's everything you would have got back with a plain old inner join. This next block is all of them that you would have got returned with a left outer join. And the last block is everything that would have been returned with the right outer join. And I guess when I say it that way, the left and right outer joins would have included the inner join part of it as well. But so you can see, based off of this, the set of nulls that we're looking at in this area here, those are all the ones that don't have a value matched up in table 2. All of these nulls are the ones that don't have a row matched up in table 1. Now let's take a look at the full outer join with exclusion. And I use the with exclusion here because it's kind of an important thing to look at. This is a way of saying, give me everything from table 2 and everything from table 1 that doesn't match up. Now conceptually, you could say here, give me a full outer join where the data is not in the inner join result set. Does that make sense? So give me everything from both tables that's not matched up or where those nulls are occurring. And all I've done is added a where clause with 2 items being checked for null. And you'll notice the or is really important here because this is one of those I made a mistake on earlier in the sample. If you put in an and, you'll never get anything back because there's no case where you're joining them up and they're both null. So that is important to be an or there. When we run this query, like we looked at before, if we ignore what we would have got back on an inner join, this set is what we would have had in our left outer join with exclusion. The second set is what we would have had in our right outer join with exclusion. And we get back those that aren't matched up. So if you had a job to filter out and maybe clean up some data, give me all of the things from this table that aren't matched up with that table or vice versa, and you had to go through and maybe do some data purging or some data cleanup or something, or maybe point these out as something somebody has to look at. Well, a great way to do it would be the full outer join with exclusion. Give me all of this and all of that and show me where they don't match at all. All right. I'm going to go backwards a slide just for a moment. And if you're following along on the poster, if you look at the 5th row down, the full outer join and the cross join, this is what I'm going to point out. The full outer join and the cross join, the Venn diagrams are similar. However, the results that you see are quite different between the two. As we saw, the full outer join we looked at earlier matches up everything that does match and gives me everything back that doesn't match. What the cross join does, if you're familiar with set logic, it gives you the Cartesian product. Or it says, give me for every single row in table 1, match it up with every single row in table 2. So if you had 3 rows in table 1 and 3 rows in table 2, you're always going to get 9 rows back with that cross join. If you had 100 rows in table 1 and 100 rows in table 2, you're going to get back 10,000 rows, or you just multiply the number of rows, and it's always going to be that number of rows returned. Not a lot of like useful normal production type stuff that you use the cross join for. However, I've used it quite a bit for building out sample data. And I think an example would be, you want to fill up a table with a bunch of data. You create like a CTE or a temp table, and you say, give me this and give me that, and cross-join everything. And it's a quick way to fill in a test table or a table on a test database with thousands and thousands of rows very quickly. So we'll take a look here at the cross-join. Notice that there is no on. There's no on clause with the cross-join. On is not allowed. It doesn't make any sense. You're just simply saying, give me everything from this table matched up with everything from that table. We had 8 rows in one table and 9 rows in the other table, giving us 72 rows in our result set, the Cartesian product. And you can see here that I'll zoom in, and for me in the list, here's the block that represents me. What it's done is it's matched me up with every possible color combination. Then next, it's matched Aaron up with every possible color combination. Have you guys ever been at some kind of a networking event or a party where they say everyone has to socialize and meet everyone else in the room? And that means I have to go talk to you, and you, and talk to every single person in the room. That's kind of like a cross join. However, the one difference with a cross join is that if you're that would be like a cross join doing a self join back to the same table. And the difference with that would be I'm not going to talk to myself in that combination unless I'm a little bit crazy. So let's take a look at how the cross join, I didn't think about this ahead of time, the cross join would work to do a self join. So we're cross joining table 1 to table 1, and we're just going to call it table T2 is the second table reference in here. Might make more sense to call it like T1A or something like that. But when we run this, and I'm just going to say T1.name and T2.name. Run that query. It joins me up with it joins everyone in the first table up with everyone in the second table. But you'll notice in the example, it joined me with me and Aaron with Aaron in the example down here, where you'd want to, if you were really playing sort of this networking game where everyone had to talk to everyone in the room, you'd want to filter out those who are talking to themselves unless they're crazy. Yes, where T1.id, it could be name, it could be ID. I'm going to go off of ID because it's an integer and just faster comparison than string. All right. So if you were faced with an interview question that said, can you describe to me the difference between a cross join and the full outer join? I think at this point, hopefully that would make sense to everyone. The cross join has no on. It gives you every possible combination between the two tables there. All right, next on to apply. Now, some people may argue that apply is not really, doesn't have the word join in it, so it's not really a join. But the fact is, it's doing a join the way apply works. So it was Microsoft's extension to SQL, and I point that out for anyone who's using MySQL or SQLite or other things like that. Apply is not supported on those other platforms in the same way, so don't think that this is going to work somewhere else. The difference being here is it's intended to be used with table-valued functions. So, but specifically, a table-valued function that's like a correlated subquery. Okay, think of it like a correlated subquery in that the values from the outside the apply can be passed into this function. Now, if you have a table-valued function that you're just passing a single value into, you can join up with that just fine. But if that value changes for every row in your result set, you can't do that with a join. You've got to do it with something else called apply. And there's two different versions. There's cross apply and there's outer apply. So if we look at cross apply, and the Venn diagram, when we look at it, is like an inner join. And cross apply is one of those that confused me for a long time. I saw sample code. I didn't really force myself to learn it. And then once I figured it out, I realized, wow, this is really darn cool what you can do with it. With cross apply, it's also known as a lateral join on, and the term lateral join actually is what's used on some other platforms. But cross apply, it's like an inner join between a table and a table-valued function, specifically where the parameters being passed to that table-valued function are changing for every single row on how it's being joined up. So let's take a look at an example of how that works. So we'll start out with table, select star from table 1. Just a quick refresher, just got a list of people there. Okay. Technically, we can use a cross apply with a correlated subquery, where here we're just saying select everything out of table 2 and join it up on the same thing we had in our inner join on clause earlier. And when we run that, we get the same thing that you would have got with an inner join. Okay, not exciting yet, but when I say that, it usually leads up to where the exciting part gets there in a minute. So let me turn on statistics.io here. I got that in the wrong spot. So I'll turn on statistics.io, which actually was already on. But if we look at it compared to an inner join, the inner join's cleaner, and we're getting the same result set back between the two. And it turns out with the small data set we've got, it's got the exact same number of reads and scans. And the plan is, yeah, it's identical between the two of those. So I think that when this is happening, SQL servers, with a correlated subquery like this, SQL Server is actually converting it to an inner join. Or at least it's got the same plan that comes out of it as an inner join is happening. So I would say if you're going to do this with a subquery, like we've done there, don't do it. Do an inner join. Makes a lot more sense. However, where it gets interesting is if you're going for a table valued function in that, as that subquery, you can't do it this way with the regular inner join. So we're going to look at a couple examples here that cross apply. If you run this multiple times or want to play with it, I've got this drop function commented out here. But we're going to create this function called getFavoriteColorMulti. I called it multi because it's being coded as a multi-line table valued function as opposed to a single line table valued function, or single statement table valued function, which if you remember the functions that we talked about recently, there's a difference there. So I'm going to create the multi, and all it's doing is passing in a parameter and grabbing the favorite color for that person with that parameter. Okay, and then if I run it, select star from that for person 2, which I think 2 is Aaron, we get green back as the favorite color there. And again, I apologize, I should have asked for your favorite color ahead of time. But if we look at messages, we get a scan count and a single logical read. Part of that is because multi-line table valued or multi-statement table valued functions hide what's really going on. So it's lying to us at that point. Okay, but let's take a look at how that compares. Select star from table 1 with a correlated subquery that's doing the same thing. We already determined earlier that that's almost identical to an inner join. Or select star from this with getFavoriteColorMulti. Instead, we're not passing through a hard-coded value, but the value on getFavoriteColorMulti is being passed in for every single row. So this function is being called once for every single row in the output. Now, as you hear that, you can immediately assume danger. Maybe that's going to put some performance load on things if it's being called a lot. Well, when we run them, we do get the same result back between the two of them. We get a slightly different sort order depending on how things came together on the results there. But if we added an order by on here, they'd come out the same. When we look at the messages, well, keeping in mind, here's what we're seeing. However, it's lying to us because it's a multi-statement table valued function. It doesn't actually report the amount of I/O that's going on. But you can see that with the inner join equivalent or the single query that it is tuning it out to run much more efficiently there. So enough bashing on multi-statement table valued functions. Let's see what happens with single statement. So we take the same thing, we throw it in as a single statement table valued function that's going to select those colors back based off that parameter. We then try it the same query again where we're using cross apply to effectively do an inner join to the results returned by this function being called once for every row. Oops, I accidentally, hold on, hit the output. Accidentally changed the output there. There we go. So we're back to the output window. And you can see that we get similar results to what we get with an inner join. Now you might look at this and say, well, that's crazy. Why would you want to use a function when you could do it as a single inner join? Well, the fact is there are certain things that you may be able to get out of SQL Server that are only available as a function. or that are easily available as a function, either by something that somebody's made in the database or because of security purposes, or because it's something that's a built-in SQL Server function that you can't get another way. And the cross apply is a great way to take that function and call it for every row in the result set and make it act like an inner join. So now what I want to do is take a look at a similar example here. I'm going to turn off statistics, and I need to turn off plan at this point or else it takes forever. I'm going to insert 10,000 values into our people table, our table 1, and see what happens differently when we have more people in the table. And then I'm going to turn statistics.io back on. And I'm using the new ID function, which gives us a GUID, and I'm casting that as a varchar to be able to just fill in a bunch of names that are GUIDs. Please, if you have children, don't name your children GUIDs, although they'd work great in the table. The way we set it up, it's a bad idea. So you can see here we have the first 8 people that we saw before, followed by a bunch of children named GUIDs. So now we're going to turn back on the execution plan. I'm going to do the same get favorite single. So we're using the single statement table valued function. We're going to run that. And it's going to give us back, because it's treated like an inner join, none of those other people in the result set had a favorite color. None of those GUID people had a favorite color. Therefore, we only got back the result of the people who had favorite colors. With this, the thing you'll see as well, though, if we look at the scan count and the logical reads, there were a lot more logical reads going on with this, with those extra rows, because it had to go through, call the function, attempt to look up and see, was there a favorite color for this person, and then return. Let's take a look now at the get favorite color multi version of the same function and compare them. We get the same result set back. We get the real number of reads. We get this temporary table that's been created that it has to store the output in that shows us that there's 10,000 reads occurring. However, because it's a multi-function table valued or multi-statement table valued function, it's hiding the actual work that's being done inside of that function. So outside of the function, it's doing 10,000 extra reads with 7 scans. And we can see already that that's going to be much more expensive than the single statement table valued function version of it. And you can see that the comparison is 7% versus 93%. Also, keep in mind, we're running on a sample database here. I didn't create any indexes or anything like that, other than the index that got created by default on table 1 for primary keys. So SQL Server is recommending that, yes, we should add an index. Absolutely, we should. But it's going to help, but it's not going to help enough. It's still going to be doing a whole lot of reads based off of the way that the cross apply works, calling that function for every result in the result set. Now, if we compare it to, let's just take the all 3 of these here, where we've got the single statement function, the multi-statement function, and a correlated subquery version of the cross apply, which we determined earlier that the correlated subquery version of the cross apply works like an inner join. And my argument on this would be, anytime you're going to do that, just do an inner join. But when we look here, we can see that it is much more efficient, and it actually maps to the same thing as the same number of reads that we get with the single statement function. And 6%, 87%, and 6%. So that tells me, with that set of data, that the cross apply with a single statement table valued function is just about as efficient as this version, which was just as efficient as the inner join that we saw earlier. There's a typical use that I've come across many times, and this is how I think I actually first discovered cross apply, was there's this dynamic view in SQL Server called dm_exec query stats. sys.dm_exec query stats. We run that. You can see you get a SQL handle, you get some information, a plan handle, creation time, this is when it went in the plan cache, whole bunch of other stuff about it. But what it doesn't tell you is what's the query. And it's got some great data that shows you what's in the plan, what's in memory as a cached plan, but it doesn't tell you what the query is. But SQL Server doesn't give you any way to go and say, just give me a table that has all the plans in it. But there is a function called dm_exec query plan. And actually, let's look at a different sample here first. If we grab the plan handle, like we take this number right here, and I think we can just say select star from that, and you get back a single plan. There's the plan. You can see there's the query associated with it, create procedure, and you can go see what plan is actually in memory at that point and what queries are associated with that. Okay, but I don't want that. I don't want to do that one at a time. I can run the first part of the select here, and I could say, give me that plan handle, and copy and paste it and call that function many times. But to do that, you can simply use the cross apply that really says, give me this initial query and do an inner join with all of the results out of calling this function for every single row. And we can then scroll over here and based off of that, scroll through all of the plans that are in memory on the SQL Server. And there's one that's probably partially cached or it hasn't, oh, it's encrypted. That's why we don't see it. It's encrypted in memory. But anything that's not encrypted, we can just click here and say, select from two tables. Select star from table 1. Somebody's having issues with posting a question. Oh, the one thing I forgot to mention at the beginning that we normally mention is if you want to post questions, you click on the grid up in the right-hand side of the, and I've got Aaron trying to answer a question. So, okay. There's one new question coming in here. It says, in case when we can use multiple checks like or, can you do that in an IIF? In case when we use multiple.
In case data is probably from last week kind of thing.
Yeah, I'm going to hold that one till the end. I'm not quite sure how it follows with what we're looking at right now, but I'll come back to that one. Can you write that one down to follow up with?
Sure.
Just we just say outer or just say IIF. That's enough to remind me. Okay, so moving on to our next one here. Yep. So on to cross apply. From cross apply, that next takes us to outer apply. Take everything we just learned about apply and how it acts like an inner join with a function, and treat it now like an outer join. Okay, call that, treat what we just learned about the inner join and treat it like a left outer join. I should have said left outer join, and you're done. You've got it. You completely understand it. It's just like a left outer join with a table to a correlated subquery or table valued function. So we'll take a look here at the same stuff we looked at before, where we're looking at table 1 with people and table, well, and the function to get the color. When we run that, you can see, and this is looking at our huge set of data that we inserted with our sample there, is that it shows Johnny and Karen here, as well as all of our unique identifier GUID people down there, because it's like a left outer join because it says, allow me to include the nulls. And just like a left outer join, you could do exclusion where you say include the is null. And I'm not going to go through each of these because it's the same stuff we run into with the single and the multi and the other function here, just very similar to the left join, or the left outer join version of applying a function. All right, equijoin versus non-equijoin. This is one of those that comes up, and although I've shown this here with an inner join, it's changing how the comparison works, and this is something I haven't used very often. However, you can use it if you need to, and you'll notice what I've done here is it's exactly like the inner join example we looked at in the beginning, but it's using a non-equijoin by using a greater than or equal to in the on clause. So join this table and that table on this ID or on this date or on this thing, but give me not just the matches, but give me what matches and everything that's greater than that match. Yeah, I'm looking around the room and I'm seeing a few very confused faces, especially Cody on this one. And I bet you what you're thinking is, why would you do that? I don't have a good answer of why you would do that. I don't think in my entire SQL Server experience I've come up with a reason to do this other than to answer the question of what's an equi join versus a non-equi join. In everything we've looked at so far, we've had an equal in the on clause, and that's an equi join. A non-equi join is where it's using something that's not equal. So let's take a look at the inner join. I guess if you really like cross join and you want to maybe filter out like the people example we had where you don't want to talk to yourself, you could use let's say everybody was sorted by age and you just wanted to talk to people who were older than you or people who were younger than you. There could be things you could do that way. So when we run this inner join with the on clause using a non-equi join, we get back, because I used equal, greater than or equal to, I get back for, as we go through here, Aaron, let's see, let me throw an order by on here because I think it would make a lot more sense. We're ordering by the thing that we're joining on. Actually, no, let me order by the ID of the first table. You can tell the equi join is something I threw in at the last minute because I think Bill asked me a question on this yesterday. So you can see okay, got it. So what it's doing here is it's going through, and for me, my favorite color is 1. So it's giving me a join against the favorite colors where my ID is greater than, my foreign key that I'm using is greater than or equal to the favorite color foreign key. Okay, so because 1 is the lowest value in the set, that is giving me the same thing an inner join would have given me because it's only equal, there's nothing greater. But Aaron, who happens to have a favorite color of 3, which we established earlier was green. Oh, blue, sorry, blue. Yeah, blue. It's saying for Aaron, give me his favorite color of blue and all of the favorite colors that have a lower ID than blue. So blue, green, red, and indigo. And then we go down the list further and we find Anne, who has a favorite color of purple. It gives 5, 4, 3, 2, 1, and 1. Kind of a weird thing, but you should know it. Just know the terms around equi join versus non-equi join. I hope you never have an occurrence to use this, but it's just one of those things you should know the terminology on. And you can do the same thing with a left outer join or a right outer join or any of the join types we're looking at here in the on clause. You can do a greater than or equal, a less than, a greater than, just anything that's just more than just the equal case, and that's considered a non-equi join. Any questions on that one? It's a bit weird.
Is that going to be on the test? That's a joke.
Yeah, and you know, it's one of those that it wouldn't surprise me, but I don't know. It's such a big bank of questions that you have there. Even if there is a question on it, who knows if you get it, right? So, all right. So that's so far at this point, we've established sort of the foundation of all of the really key join types versus some of the wackier ones along the way. And now we're going to take a look at some combinations of how, and this is where I really like the Venn diagrams because it gives you a better description of what set you're getting back. So if we do 2 inner joins, if you remember the original inner join picture, it showed a single inner join gives you the intersection of those 2 tables. Whereas with a third inner join, it makes the data set even smaller unless one of them is completely encompasses the other table, but it makes it even smaller. So every time you put in an inner join, it's kind of restricting the amount of data that you've got there. unless two tables are an exact matchup. So if you had 10 inner joins, you would see that the amount that's getting returned gets progressively smaller and smaller and smaller as you go. And the way that SQL Server accomplishes this is it analyzes it and it figures out what are the best two tables to join. And I don't know what the algorithm is there, but they do a really good job of figuring it out. And they join the first two tables. And then the third table gets brought in, and then a fourth table gets brought in. And as you go through it, SQL Server does it very efficiently to join all those tables. And the order of the tables that you specify in your query doesn't really matter for performance, other than the table you start with as your very first table. If you've got a chance to use that as a small table in the from clause, please do. Because that will start out with a small set that then gets joined of multiple joins, and you're starting out with as small a set as possible. Whereas if you had the first table was a really big set joined to another big set, it's going to be a big set of data that's going to be continued until it gets filtered down. But as far as the from is the one that's usually included in the beginning, but then everything else through the inner joins, SQL Server does its own thing to figure out what the best order is there. Two left outer joins. If you remember from the left outer join, it says give me everything from table 1 matched up with table 2, and if it's not in table 2, give me nulls. In this example, we're saying give me everything from table 1 matched up with table 2 and table 3. And if it doesn't happen to be in table 2 or table 3, give me nulls. But if they do match up, give me the data from those tables. I'm going to go through the slides on these, and then I'll jump through and actually run the code on each of them. Inner join and an outer join. Well, the inner join says give me everything from table 1 and table 2. Think of that as one result set. And then let's take that as a left outer join to table 3 and give me everything out of that inner set that exists, the first inner join, and everything that happens to be in that second set. So that's the top and the bottom half of this piece here. So the outer join does not reduce your set by size. The inner joins generally do. Two full outer joins. Okay, full outer joins, remember for table 1 and table 2, it was give me everything from both tables that matches up, plus give me everything from table 1 and match it up with nulls if it's not in table 2, and everything from table 2 and match it up with nulls if it's not in table 1. In this case, it's going to say include all of that joined up with table 3, but if table 3 doesn't match up with any of that, keep those as nulls too. So let's look at the example of that. So two inner joins, and table 3 had 3 rows in it that were 3 foods, pizza, sushi, and something else. So if we look at inner joining table 1, 2, and 3, the only person that actually had a favorite color and a favorite food based off of this was Beth. Her favorite color is yellow, and her favorite food is pizza. And again, bad naming here, but I'm just trying to keep the table simple for what we're doing. So we only got a single row back there. It gave us the same thing we would have got with a single inner join, but then filtered it down, and it gave us more columns. Two left outer joins. Hold on. On this one, I'm going to go back and recreate the data and get rid of all those GUIDs we were working with. So two left outer joins. Here you can see we have Beth, who was our favorite color, yellow, and pizza. So that was the person who was the inner join between all 3 tables. Combined with all of those who joined up between table 1 and table 2, but didn't match up with table 3, which is our original inner join between 2 table sample with a few extra columns. And then all of those who matched up with a favorite food, but did not match up or would have been on the left outer join with left outer join with exclusion set, but they're matched up with their favorite food at this point. Okay, next on that was the inner join with the left outer join. Oops. So the inner join, if you remember from our first inner join example, oops, wrong key. This set here is exactly what our original second query that we ran of the day returned. It's just the inner join between the first two. But then we left outer join to the pizza, which said, give me the favorite, or we left outer join to table 3, which gave us the pizza, which is the favorite food. Give me the favorite food for anybody who matches, but if it doesn't match on the favorite food, that's okay, just to return the result sets with null. And hopefully you can see at this point as we go through the multis here, how convoluted it may get if you've got 8 or 10 or 12 of these in a query to just understand what is it I'm actually getting back. So it's nice when you're working with these really big queries to have a way to break it up into smaller pieces where you can sort of conceptualize it a little bit better. So then 2 full outer joins. Give me everything joined up from all 3 tables where it would possibly join up, and give me everything that doesn't join up and fill it in with nulls. And the one result that we got back on this query here that we did not get back on any of the other ones was sushi. Because sushi was the only food in the favorite foods that wasn't liked by anyone. They must not be from around here. And that's it on the sample. So, gone through a lot today. Had a couple great questions along the way. Any questions at this point? And there, I'm just going to address the one question. There was a question around somebody was having trouble understanding with the case statement. Could it just go into an IAF? That's last week's or week before, whichever week we did that. The video is available on my website at stevestedman.com/YouTube. You can find it there if that's what you're going for, because I don't exactly understand what's being asked in that question. Any other questions on anything we've covered this week? Any there?
No.
Okay. Did everybody learn something new and interesting or bizarre? All right.
So when you're logically going through the process of creating a series of joins where you have more than just one, because all these are just ones.
Yep.
Well, not all, but you get 4 or 5. Do you kind of like in your head kind of say, okay, I got this first batch, and then I'm going to take that and think of it as a subset, and then think, okay, I'm going to left join that with this, and now I think of that as a subset kind of thing as you go down, or how do you logically come up with a complex query?
So on those bigger ones like that, I don't think I'm good enough at SQL Server to be able to just start typing and write out like a 10 query inner, left, right, outer join combination of 10 different tables in there. I mean, my brain can't comprehend that, and all in one single stretch. So what I start out with is keep it simple, is 2 tables. And all I'm ever thinking of is 2 sets. So we do 2 tables that establish it, or 2 tables on some kind of a join that establishes a simple Venn diagram in my head that describes, here's this first join. And then conceptually, I take whatever the result sets are with that and join it to something else. And that's a second Venn diagram in my head. And then I introduce them one at a time or another at a time, or I might build 2 completely different queries and bring them together as 2 different subqueries or something. But I get really confused with joins like that when there's more than 2 or 3 of them. And I find it really, really hard to conceptualize. So I do them one at a time. And sometimes I'll draw a Venn diagram where I draw one circle and then another circle, and I end up with about 8 circles by the time I'm done with it, as I'm going through and analyzing what already exists. But if you're looking at it from scratch, just do them 1 or 2 at a time. Is that what you're asking? Mm-hmm. Now, I say when you're looking at them from scratch, do it that way, but you don't always have that luxury. Go work on a query where somebody's already joined 12 tables together. What I like to do in that, if I have to go maintain or change a query, is start at the top and just start commenting out huge chunks. Comment out like all the inner joins and see what's missing or breaking because of that, and then comment out all of those things that are breaking, and then just step through it one by one by one, like I was creating it from scratch. Because it's just too convoluted to conceptualize that.
Kind of one thing Gabe alluded to is how do you do it when there's like bad data in some of your tables, so like one table all of a sudden has double rows, and all of a sudden the whole result set is doubled instead of what you really wanted.
That's a good question. And when you've got bad data, hopefully you've got some way you can go through and clean up that data, but that's not always. Sometimes you're just stuck with it. And the way I've seen it done, and I recommend not doing it this way, is to just put a distinct at the very beginning of your select. Bad move, because it's doing all the work to bring back all of that duplicate data, and then it's doing all the work to filter it down. So anytime I see like a table with lots and lots of joins with a distinct at the beginning of it, that usually tells me there's either bad data or someone really didn't know what they were doing on the joins. Sometimes it's the right thing to do, but most of the time it's one of those two things. All right, what would be better would be to figure out how can you bring back distinct data at a specific location if there's that duplicate, or if there's a way to filter out the duplicates, rather than bringing back, then filtering out at the very end.
There's no guarantee which one you're getting.
Well, if they're duplicate, yes, you're right. Well, if they're exactly duplicate, no, there's no guarantee which one you get. But if they're exactly duplicate, you don't care because they're the same. But like in the example of the bad data with the colors, my favorite color is red and indigo. That's not true, but that's what the data showed. In that case, you got to go clean up the data, because there's no way in a query I can determine someone's favorite color if there's two colors being shown there. And distinct wouldn't fix that one, for example. So, does that answer what you were looking for there? Hopefully.
It's just hard, and there are a lot of times you end up with double what you want, you know, or just doing a report or something, right?
And that's a sign of generally two things that I've seen. One is there's bad data somewhere, and or maybe it's not understood, and then the second one is the query is not filtering appropriately. And sometimes it will be, when I say not filtering appropriately, you might be joining on a table that has, based off of all of the columns, they're different rows, but by what you're asking to get back in the result sets, they're the same. And you might need to add additional filtering or do something to make it more distinct early on in the query. Any other questions? All right, so next week we're going to cover stored procedures. And I just published this version of the chart yesterday, or the poster yesterday, and based off of at least one typo that I found in here, and any others that you guys might have caught while I was going through it, I'll put version 4 out in the next day or two, hopefully. So that wraps it up. For more information, you can visit Emergency Reporting or Aaron or me on the web. Have a great day.